one thing I forgot to mention about the theorem was that instead of the coefficient of the biggest monomial of our polynomial should be 1 in order to use that theorem, the rest of the coefficients should be integers. Now, for instance, something plus 3x to the power of 4 minus 10x cubed, whatever. And if the coefficient of the monomial with the biggest degree be not 1 or be some fraction, for instance be something like over 3 x to the plus 3 x4 plus whatever. So here we multiply the whole polynomial by 3 and divide the whole, multiply by 3 and divide by 3, and finally we divide it by 3, but first we multiply by 3, so the coefficient of this becomes 1. Or if any coefficient would be fractions of the rest of the monomials, for instance, suppose instead of 3x to the power of 4, this was 3x to the power of 4 over 4. So again, we could first multiply the whole polynomial by 4, and finally we divide the whole by 4. Anyway, but what if, for instance, suppose we have something like that, plus 3 over 4 x to the power of 4 plus x cubed plus whatever, and so the coefficient of this is not an integer, so we should multiply by 4, so that would become 4x to the power of 5 plus 3x to the power of 4 plus 4x cubed, and finally divide by 4. Okay, so here are the coefficient of the monomial with the biggest degree becomes some integer but 1. So how should we factor such thing, or find the values of x which makes that 0? Or that would be one case in which the coefficient of that is not 1, and maybe there are other cases in which you are given to factor the polynomial in which the coefficient of the monomial with the biggest degree is not 1. Say something like that. 3x to the power of 4 plus x cubed minus 2x squared plus x plus 1. Here the coefficient of this is not 1, it is 3. So I use the similar way, similar method. I talked about it in the factorization videos, in some of the previous videos. And here we multiply the whole polynomial by 3 cubed. So this becomes, let me do it here. We multiply the whole by 3 cubed. So this term becomes 3 to the power of 4 times x to the power of 4. And now we write it as 3x to the power of 4. And finally we divide it by the same number, so that doesn't change anything. Okay, that would be this plus 3 cubed x cubed, that is 3x cubed minus 2 times 3 cubed x squared, and we write it as this. Write this as 3 squared times 3. 3 squared times 3 times x squared. Okay, and again we write it in the form of 3x. That would be times 3 times 3x squared plus 3 cubed x. Again we write it as 3 times 3 squared, like that. 3 times, or 3 squared times 3 times x. So here we again have 3x plus 3 cubed. Now, here, instead of 3x, write y, or take y to be equal to 3x. And that is y to the power of 4 plus y cubed minus 6y squared plus 9y plus 27. Okay, now here the coefficient of that is 1 and the coefficient of the rest is integers. So according to the theorem, the possible integer values of y which would make it 0 are the divisors of 27. Let's solve it. What are the divisors of 27? It is plus or minus 1, plus or minus 3, plus or minus 9. That's it. And plus or minus 20. Okay. So let's try by plus or minus 1, which makes it 1 plus 1 minus 6 plus 9, 27. This is not 0. Minus 1. Minus 1 makes it 1, minus 1, minus 6, minus 9. This is not also 0. And for calculating it for y equals plus or minus 3, we use the method. We write it as y cubed times y cubed, and we substitute plus 3 into this, the first y. That would be 3y cubed. Here we got plus another y cubed, that would be 4y cubed. Again, we should write it as y squared. So this is 4y squared times y. Y is 3, substitute 3 into that. That would be 12y squared. 12y squared minus 6y squared would be 6y squared. Again, write it in this way, in this form. 6y times y is 3, substitute 3 into one of the y's, that would be 18y. 18y plus 9y would be 27y, and plus 27, and this is for y equals to 3 is not 0. So let's try the minus 3 again by the method y times y. This is y times y cubed. Substitute minus 3 here. That would be minus 3y cubed plus y cubed would be minus 2y cubed. Again, write it into the form of y squared. Y squared times y is minus 3 times minus 2, 6. This is 6y squared minus 6y squared. Cancel each other out. We got 9y plus 27, which for, if you substitute minus 3 into that y, that would be 0. 9 times minus 3 minus 27. Okay, so y equals to minus 3. So that means that y minus 3 is one of our factors here, which is y plus 3. And after dividing it by this, now we determine the rest of the factors, and finally the polynomial we want to factor was a polynomial of x, but here we got y, so we, instead of y, we write 3x here. 3x plus 3, and whatever the y we got here, we do the same work for them also. Okay.